Okay, can anyone tell me any element which you have written? One by one, one by one. Hydrogen. Okay, one by one. Yeah. Ismail, start telling me. Hydrogen. Next. Helium. Next. Magnesium. उसके बाद sodium. Okay, next. Cadmium. Next. Calcium. Very good. Beryllium. Then francium. Okay, next. Okay, tell me a metal which is in liquid state. Yeah. And what is this notation? Hg and full form? Yeah, full form. They're asking you this question. Okay, I'll show you the previous year question papers. But today let us do little bit basics. The chapter which we are going to do now is deleted by the NCRT. Okay, so you can relax and watch those who are in board or and your board exams. But NDA, CDS, afcat, those students, those people have never deleted it. Okay, and they will never do it. Fine. So look at this. You can see address, arrangements, and the second one. Which one looks better and beautiful? Second one. So when you keep something in order, it looks beautiful, right? Okay, which place will you choose for shopping? Okay. Okay, fine. Look at this. Okay. And look at this. Okay, you try to go and buy books from the first one. Okay, it looks beautiful when it arranged, and it becomes easy for us to study about the property. So this is called as element table. The future generation from this year, they will never come across this something called as element table. So we will be having a lot of Abdul Kalam in futures. Okay, so देखो ये है element table. So the first one there we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Okay, it goes on. What you should remember for your exam is, okay, what you should remember for your exam is this one. Okay, element table, that is inert gases: helium, neon, argon, krypton, xenon, radon. Okay, now the question in your exam will be like, which gas is present in electric bulb, which gas is used in is manufactured in laboratory artificially. Okay, this kind of questions they are going to ask you. What is lanthanides, what is actinides, all these things are there in this element table. So we are doing a small part of chemistry. Okay, and remember, chemistry is nothing here. It is just arranging some elements, then doing some experiment with chemicals, and nothing special here. In physics, if you know some laws, you can invent something. Like for example, if you know electricity and if you know the property of metal, you can invent electric bulb. Okay, but here in chemistry, you don't have nothing much of invention, but we have discovery and experiments. So maximum here in chemistry, you have some scientists like John Dalton, atomic theory. Then you have J.J. Thomson, atomic, those that they will ask you. Yeah, Rutherford. Okay, then you have the person who gave this element table. Okay, so Mendeleev element table. So who is that person? That's it. In chemistry, you have only this. Then you have to do some experiments. Okay. So now let us try to understand. Element is a type of matter composed of only one kind of the substance. Okay. Initially, scientists discovered elements like gold, silver, carbon, sulfur, iron, and copper. They classified them as metals and non-metals. So copper, silver, iron, these are all metals, and non-metals we have carbon, gold, sulfur, these are all other examples. Okay. But when it comes to silicon, there was a question whether it is a metal or a non-metal. Okay. So some elements showed properties of both metals and non-metals, and today we call it as metalloids. Today there are how many elements? 119 elements. So whatever we are going to see now, this happened just 200 years back. There was a revolution called as industrial revolution in Europe, in England especially. Okay, a person, he had a technique of manufacturing iron, smelting of iron, Kirti, smelting of iron. Okay, so how to manufacture this iron in a large quantity? That is how industrial revolution started. So from iron we have steel. Okay, and then we have different kinds of iron, that is pig iron, wrought iron, correct? Then we have iron ore, hematite, lignite, magnetite, Right? These are all the questions asked in your examination. So look at this, few examples of elements. Tell me this quickly. What is this? Hydrogen, helium, oxygen, neon, copper, boron, potassium, lithium. Okay, once again. Yeah, start. Beryllium and thorium. Okay, so then this one here, this is radioactive. Okay, it is radioactive, and thorium is found maximum in India in Kerala coast, in coastal regions of Kerala. Do you understand? So this is thorium. Then we have radium, uranium, like this. There was a need of systematic classification because all the elements are arranged like this. I have to arrange them in a proper manner. So many scientists, they try to do some like for example John Dalton, JJ Thomson. We have many scientists who try to do something their best. So here we have a person. This person will be seen in physics also, once again in atomic chapter. He proposed the atomic theory. Okay, five postulates of atom theory. Atom is the smallest particle of an element. It can neither be created nor be destroyed. Right? Yes. So like this we have John Wolfgang Daubernier. Okay, so this there is initially we have just stories key, how this element table came into existence. So he started classifying elements on that basis of properties. Properties means melting, boiling. Okay, what is the difference between melting point and boiling point? Yes, what is the difference between melting point and boiling point? What is the boiling point of water? 100 degree Celsius. Okay, boiling point means the phase change. It will change from the liquid to the gas, liquid to gas. Okay, so Daubernier, he tried to arrange them in the properties. So we have Daubernier law of triads. He arranged chemical similar elements, the increasing order of their atomic mass, and in a group of three. So like this, he started arranging. Okay, lithium, sodium, potassium. Okay, like this he started doing it, but this also failed. We will not study this in detail, but because it is not important for our exam point of view. Okay, then this failed. These are all Daubernier triads. If you are free, you can read the NCERT 10th standard textbook, that is chemistry. Old textbooks, not the new one. So the limitation of Daubernier theory, at least you have to read the limitations. It identify only few triads from the elements known at that time. Other triads did not obey the Daubernier's rule. Okay, next. After Daubernier, we have John Newlands. So in chemistry, we will just see this kind of individuals. Like in medieval history, we have kings like Alauddin Khilji, Muhammad bin Tughlaq. They just came and they just left, right? Like this in chemistry, we have this kind of people who just come and they try to contribute, and finally there will be an individual who was successful in arranging this thing. So after the failure of Daubonnet triad, this man, he discovered 56 elements. Okay, and if you see, whenever we take a topic of science, we never come across any Indian or African scientist or South American scientist. So because the science, the concept itself is from Europe and America. Understood? And even today, the technology is in the hands of the Americans. Okay, so today's news, the jet, the deal which we have done it, only 80 percentage of the technology will be given to India. So they are not ready giving 100%. US, France, Russia, okay, US, France, Russia, and England. Only these four countries they have technology. Countries like India, we don't have technologies. Okay, that's why we are falling back. Even China has technology. We are not having power to overcome these people here. Look at this now. Elements and symbol. Okay, tell me, hydrogen is, what is the symbol of hydrogen? Which battery you use in mobile phone? Why? Yeah. No. Why do we use lithium as in our battery? Why don't we use copper battery or aluminum battery or iron battery? Okay, the answer is lithium is a metal. First answer. Second answer, lithium is the lightest metal. What is that? सबसे हल्का है. हल्का मतलब it is very light in weight. If I use iron battery, you require two persons to carry your mobile phone. Do you understand? And so that's the reason here. Lithium. Next, beryllium. B. Boron. B. Okay, this is, he is a culprit. Okay, carbon is very dangerous here. There is a special chapter and very important chapter for your exams, that is carbon and its compound. Nitrogen N. Tell me. O. Calcium. Do you understand? Okay. I will show you after this chapter gets over. There is a special paper. Yesterday I have seen it. Among this, whatever I have shown you, यहाँ से एक question पूछा था. What is the the notation? How I will write mercury? How I will write gold? ऐसा करके question पूछा था. So this element and its symbol, you should know it. ठीक है? Next, increasing order of the atomic mass. He studied physical and the chemical properties of these elements. Okay, that is John Newland, and started arranging in this way. Okay, so they tried a little bit, but look at this. This is called as octave. Last class I asked you a question on the calendar. Okay, why some month is named as July? Why? Julius Caesar. Okay. Next, tell me why the month is named as October. September के बाद क्या आता है? Yeah. Tell loudly. October. Count which month is that? Yeah. Eighth month is called as? Tell loudly. October. Okay. Which animal has 8 legs? Yeah. So what is common? OCT. Oct. Oct means 8. What is that? Oct means what? 8. So octave. Octave means 8. You understand? Next, those who know music, in keyboard, you have 8 keys. How many keys you have? सबको सारेगामा आता है? Count how many letters are there in सारेगामा? Huh? Wait. October is 10. No, oct means 8. Okay, hexagon is 6, right? Deca is, yeah. Okay. Pentagon is 5. Okay, fine. I'll just check it, but octa means 8. Okay, I'll come back to that. Next, look at this. Octave. Oct means 8. Okay, so sa, re, ga, ma, pa, da, ni, sa. Kitna hai? 8. So same thing in English music system also. C, D, E, F, A, B, C. Like that it happens. So what this guy has done, he has arranged this in this way. Okay, sa, re, ga, ma, pa, da, ni. Okay. Next, high pitch, low pitch. Okay, so like this he even tried to arrange. ये सब technical है, इतना detail में नहीं चाहिए हमको. We don't want that much in detail. So that's the reason I'm running up. Next we have Mendeleev, finally a Russian chemist. Okay, he was successful in arranging based on the atomic number. Okay, so look at this 1869. Can you see this year? The year when Gandhiji was born. Okay, remember this. And 20 years later Hitler was born. Okay, so he is also called as father of classification. He is also called as father of classification of the elements in the element table. So the most important contributor is classification of elements. Mendeleev knew 63 elements. He classified elements on the basis of atomic mass and studied their physical and chemical properties. And he took the formulas. ये सब story है बस. Okay, I'll just directly go to the element table. Okay, look at this. What is meant by period and what is meant by group? Imagine the element table looks like this. The horizontal rows, okay, like this. Imagine. Can you see this? This horizontal rows, this is called as period. Okay? And if you draw a vertical line from top, it is called as groups. This is period, and from top to bottom it is group. In your exam, the question is asked like this: the atomic size of the element increases towards the period or decreases towards the period if you go from left to right. What will happen to the atomic size if you go from left to right for the in the period? What will happen to the atomic size if you go down the group? So up, down the group, up the group, left side, right side, ऐसा पूछेंगे. You know, in India map we have practiced like that. Okay, India map, the rivers from the south to north, north to south, east to west. The same way in physics, they will, in chemistry, they'll ask you questions like that. Okay, main features of the Mendeleev table. Okay, ये सब story है directly. Just a minute. Okay, look at this now. So here you have periods, horizontal rows. या हाँ जाओ जाओ. Okay, so here you have periods which is horizontal and this is group. ठीक है, long form of the periodic table. अभी we have 18 groups. Look at this, how many groups we have? 18. So 18 lines we have and 7 periods, that is 7 rows. Okay, modern periodic table looks like this, very important. So this is 7 periods are numbered from 1 to 7. There are two ways to number groups. All tall columns are labeled as A and short columns as B. Okay, so 1A, 2A. Can you see this? 1A and 2A. Then on the right side you have 3A, 4A, 5A, 6A, 7A. And last one is 0. And the short one will be named as B. Correct? 3B, 4B, 5B, 6B, 7B, like that. You understand? So other way just to number from 1 to 18. So this is how it is numbered. Can you see that top? ऊपर देखो अभी सब लोग 1 to 18 मैंने number दिया है, ठीक है? So in modern periodic table, elements are arranged in increasing order of atomic number. So let's put atomic number from 1 to 116 in each box. Ready? Okay. So what is the first element here? Okay, I'm putting number here. I'm just putting numbers now here. So I'm putting 1 here, 2 here. Okay, then 3, 4, 5, 6, 7, 8 till 10. Then 11 to 18. Okay, next. Look at this. 19 से लेके किधर तक है? 36. Is it continuous or discontinuous? After 36, what should come there? Okay, so shall I check now? So 36 से continuous. Look at this. 38, 39, 42, 46, 54 तक है. Now next, what is the next number down? 55, 55, 56. After that, there is a problem. What is that? There is a gap. Okay, is there a gap? Okay, so this gap now, 57 to 71, is called as lanthanides. This is called as what? These are called as rare earth metal, lanthanum, lanthanides. Okay, so 57 to 71, it is like this. 86 इधर है. 86 के बाद नीचे क्या आएगा? What will come down? 87. Okay, so look at this lanthanides. Okay, now look at this. After 86, you have 87, but there is a problem with 89. Look at that. So 89 to 103, what is that? This is called as actinides. Okay, so lanthanides on top, actinides bottom, but you should remember 57 to 71, 89 to 103. Do you all understand? Okay, so start from first. What is the first element? What is the first element? Hydrogen. Second, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, so now this is how we are going to fill it up: potassium, rubidium, cesium, francium. In exam, there was a question. This cesium is nothing but a metal which is used in atomic clock. Okay, remember this. Then here, helium, neon, argon, krypton, xenon, radon. These are all inert gases. Okay, so like this also we can fill it up. Lanthanides, actinides. Okay, so this is how the element tables looks like. सबको समझ में आया? Okay. Now this is the another important part. So can you see the red color one? These red color column which you can see, the groups, two groups which you can see, that is alkali earth metal, light metals. Do you understand? Light metals. So tell me, lithium is a light metal or a heavy metal? Light metal. Okay. Next, heavy metals. Now tell me, iron will come in light metal or heavy metal? Aluminium, copper, heavy metal. Silver, gold. Okay, next, the green color is non-metals. Green color will be non-metal. Okay, next. Now one more observation you should see. Here I am telling you this is non-metal. This is oxygen and nitrogen. So oxygen is a metal or a non-metal? Nitrogen is a metal or a non-metal? Helium, neon, argon, krypton. They are inert gas, but yeah, but a kind of non-metal thing because they don't conduct electricity. There is one more observation. Oxygen is a gas. Nitrogen is a gas. Yes or no? Helium, neon, argon is a gas. Now if you see these metals, they will be in solid state. Maximum of the metals will be in solid state. Lithium is solid or liquid? Lithium, solid. Iron is solid or liquid? Okay, so this is also, you should keep one thing in mind. Group 1 and 2, okay, electronic configuration. Sodium, okay, this is 281 and magnesium 282. So all the elements in group 1 and 2 will have either 1 or 2 electrons in the outermost orbit. Okay, this point you should remember. I will draw a diagram and I'll explain you, but right now you just understand all of them in the order become stable, donate electrons, therefore all metals except hydrogen. Since only outermost shell is incomplete, they are called as normal elements. So they are very good in conducting electricity. Why? Because the last orbit it has only one electron, otherwise two electrons. So two electrons can easily go and conduct electricity. Now this will be opposite. The last orbit will have only one vacancy, only one empty. Imagine all the elements in this block contains 3 to 8 electrons in the outermost orbit. Okay, look at this. The yellow line which is going now. So above this we have non-metals and below that we have metalloids. So zigzag line in this block divides entire periodic table into two parts. This block contains metals and non-metals as well as metalloids. Can you see this yellow line which it came now here? Above this we have non-metal, above this we have metal, but this region here, this is called as metalloid. Have you heard silicon, germanium? This all comes here. Silicon, germanium का घर address इधर है, ठीक है? Next, metals, non-metals. Okay, look at this now. Boron is a metal or a non-metal? Arsenic, beryllium, okay, polonium. So these are all metalloids. Okay, look at this now. Chemically inactive. Next, in between group 3 to 12, we have heavy metals. So for example, we have Fe. What is Fe? Fe, क्या है Fe? Iron. Now those who are writing competitive examinations, the questions will be like, what is the name of iron ore? Fe2O3 or Fe3O4? Hematite, lignite, magnetite. This is geography question. What is iron ore? What is the best, from where I can get iron? Which is the best iron? Like, hematite, magnetite. But in chemistry, they will ask you, what is the chemical formula of iron ore? Fe2O3 or Fe3O4? Both. Both. Okay, we have both. So the answer is both. So these are now, for example, lanthanides and actinides. Okay, these are all very rare earth metal. So this is how your element tables look like. So look at this, the black one which is now coming up here in the slide, these are all alkali earth metal. These are called alkali earth metals. Next, electronic configuration, they have only one electron in their outermost orbit. So if you see this, okay, if you see this, hydrogen in the last orbit we have one electron, lithium in the last orbit we have one electron, sodium, potassium, rubidium, all this will have how many electrons in the last orbit? One. Keep that in mind. Okay, so that is what is the, so look at this. 1, 1, 1, 1, everything is 1. Yes, hydrogen last orbit 1, lithium last orbit 1, sodium last orbit 1. Okay, see, hydrogen is also having one electron, lithium is also having one electron. But why I am not using hydrogen in my batteries? Why I am not using hydrogen in the batteries? Why I am using lithium in my batteries? Yes, hydrogen is gas, one correct answer. Any other reason? Correct. Is it right? Hydrogen is gas. So can I use gas in batteries? That is correct answer. Second answer. Does not conduct. Okay. सही है, gas नहीं करता है, but ठीक है. Okay. The other answer is like this. Hydrogen has a calorific value. मतलब it has, suppose it is a gas, it can burn itself. So if I use it in battery, we are not creating batteries, we are creating bombs. Okay, it may explode. Do you understand? Look at this now. Hydrogen and the halogens. What is the similarity? Here hydrogen will have one electron in the last orbit. Here these people are hungry for one electron. That is the reason here hydrogen will always combine with chlorine and we get hydrogen chloride, HCl acid. Have you heard it? Okay, look at this now. Hydrogen, chlorine. Okay, electronic configuration. Actually, this I have to take it from the basics. What is atom? What is valency? All these things. Okay, these are called as halogens. Okay, group number 17, fluorine, chlorine, bromine, iodine. Okay, next, inert gases. Zero elements are called as inert gases. Helium, neon, argon, krypton, xenon and radon. Yeah, the most important slide in the whole class, you can say it is this one. So those who are preparing for UPSC examination, if you don't understand this chapter, it's okay, but at least you by heart this and go for the exam. N number of times, every time in chemistry they will ask you this question only: what happens to the ionization energy if you go right towards the period? It increases or decreases? It increases. Electron affinity towards right increases. Atomic radius down increases. Okay, electron affinity up the group, okay, it increases. Like this they are going to ask the question. Atomic radius towards left, from right to left, it decreases. Okay, so this chart if you understand, you can definitely write one answer in your exam. Okay, valency, atomic size, metallic, non-metallic properties, etc. Okay, now for example, you might have heard about a shell called as KLMN, right? So look at this. Sodium, we have totally how many electrons? 11 electrons. So 2 plus 8 plus 1, how much you get? 11. Okay, next. Magnesium, 12. 2 plus 8 plus 2, 12. Okay. So number of valency is nothing but the number of electrons in the last orbit. So what is the valency of sodium? 1. What is the valency of magnesium? 2. Aluminium? 3. Silicon? 4. Phosphorus? Sulfur? Chlorine? Argon? Here the last orbit is already filled, so it will never react. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now this, as the number of electrons are increasing, they are less reactive. Okay, now chlorine, it will react only with hydrogen. Okay, so look at this now. Okay, chlorine, now these are all like little technical questions and answers. Okay, these are all theory part. I told you the atomic size increases towards down the group. Okay, see now. Okay, now right side में जाने के time, okay, the atomic size remains the same. Okay, if you go towards right, the atomic size remains the same. Look at this, everywhere it is same. Next, suppose if you go down the group, okay, now you are going down. Fluorine, chlorine, bromine, iodine. This is fluorine, this is chlorine, this is bromine, and this is iodine. What is happening to the atomic size? So when you go down, halogens, when you go down, the size increases. Okay, next, that's what they have mentioned here. Okay, now metallic and non-metallic property. Look at this. Lithium is a metal, sodium is a metal, potassium is a metal, everything is a metal. Look at the last orbit, how many electrons I have? Only one electron. Okay, so the metallic and non-metallic property character down the group, it increases. Okay, the metallic property increases. Chemical reactivity. Now, what is more reactive? Sodium or chlorine? Sodium. So, very reactive, least reactive, and very reactive. Now very reactive, in the case it depends on the other agents. Okay, now look at this, chemical reactive decreases and again it increases. Okay, again it increases. So in the center of the group, when I am drawing this metals, that blue color one, it changes from that side. Now for example, lithium, sodium, potassium, rubidium, these are all the metals. The chemical reactivity decreases down the group. Okay, so whatever chart I showed you, the same chart they are explaining. Once again, we'll do this in detail because it's becoming technically little heavy. पहले आपको first you should know what is atomic radius, okay, what is ionization. Just a minute. Okay. So the most important slide which you guys should by heart is this one. Okay, I have another slide for the same chapter. I'll show you that. At that time it will be easy. So did you understand this? Yes, switch on the lights. Yeah, and revise whatever we have done till now. Revise quick.